So, hello world, my name is Kristopher Driver. Welcome to another YouTube exclusive extras edition of Frivolous Gravitas, offering educational resources without ads or sponsors. That means you can show your support simply with likes, shares, and comments, just to help keep the channel going, and without further ado, we'll get right into it. So for today's programming live session, I just want to start off with a bit of a precursor here. I wasn't sure if I was prepared to keep doing these introductory programming videos initially, but now that I've committed to making a few more, I think it makes sense that I take a minute to explain my approach and motivation for doing these videos. Sorry if it's a bit rehashed from the first and second, but I figured it makes more sense to just put it all in one spot and then I won't have to do it again. So, regular listeners of our weekly podcast may remember that I've made mention once or twice to a research project that I'm working on in the field of machine learning artificial intelligence. And in working on this project, I've had to go back to some programming fundamentals to hone my craft a bit, which led me back to playing with code in a web browser because of how quickly and easily I can sketch new concepts for prototypes without having to keep track of workspaces or jumping between multiple project files or saving useful bits of logic that I can translate into other programming languages as tools later on. I realize that these live coding sessions have actually been really helpful for me by reinforcing some fundamentals. Like, for example, the last episode I did on functions. At the end of it, I sort of started tripping over the sort method, which is a rookie mistake, but it happens even after 20 years of experience. So, I guess having used newer tools for so many years, the issues I stumbled across with the array method, like sort, from the last episode, just never really came up that often for me, so I kind of forgot all about it until I made the last video. After I played with it a bit, I realized my code was sort of broken, in that it wasn't producing the expected output. The sort method was changing all the references to the array that I was sorting, not just the array that I applied the sort method on. And that's sort of what got my confusion going. And then I remembered, I had done this years ago. I stumbled across the same problem and quickly found a solution to it. But the first time I came across it, it definitely wasn't a quick fix. I didn't understand it at all, and it took forever to figure out what the problem was. So by the end of the video, we'll get into that, and hopefully I'll explain it better than it was explained to me, so maybe you'll catch on, or maybe you're just sharper than I am, but hopefully you'll catch on right away, and so you don't get tripped up with the same problem I had. So today's live session and talk is about methods, aka functions that are built onto lists or data objects. One of the big reasons I'm doing these coding sessions, though, is playing with the versatility of the JavaScript language, since we can run JS code in any browser and keep everything we need to run that code completely contained within a single HTML file, and since we don't need to build an executable and run the program every time we want to test a line of code, and also since web browsers are basically ubiquitous, they're everywhere, we can easily render our JavaScript into visual, interactive objects, which I think, anyway, it's a great place for everyone to play around with ideas. Having a browser that can render something visually really gives you that instant feedback that helps the learning process move forward. But in addition to that, we can even write useful tools, which can then be applied to any business or industry or run on any device from anywhere in the world, because JavaScript's not just for web developers or software engineers. You can actually write logic and code out of it. And that's definitely useful. So JavaScript, a little background, I guess. JavaScript has a bunch of free libraries, and a library is just basically somebody else's code, but you can do useful things with it and not have to write it from scratch like reinventing the wheel. It can be loaded and run from inside a bunch of other programming language environments too, JavaScript that is. And there's no shortage for tutorials online, so it's clearly a great tool to get started with. In addition to fully fledged frameworks for things like machine learning with TensorFlow, like I'm sort of building up into doing, or for app building with frameworks like React, JavaScript can actually also be used to make custom tools for businesses and organizations which may not typically be otherwise associated with computation or programming at all. So for instance, I think I used the example before of an estimate calculator for pricing formula for independent contractors to provide quotes for services. Another example, though, might be automating tedious processes like collecting up-to-date information from a website rather than manually checking, writing down market data manually every day. You could have a JavaScript code that does it and stores it for you. So naturally, every business these days also needs a website, so there's the obvious benefits to learning browser development and web development and scripting and things like that for web technologies in general. But I just want to make it clear that it's also very useful outside of its practical application. Another reason for JavaScript that makes it so useful to everyone is how easily it can be converted into another programming language. So like transpiling, which is the word for that, is just like translating and compiling put together, transpiling. Transpiling JavaScript is easier than ever using free tools like Babel. So even if your intention is to go into computer science through like Python or Java or something like that, you can actually convert JavaScript code, the logic, into another programming language that will run and almost perfectly, but not exactly perfectly, run the exact same code in a different language, which is very handy, because if you know one language better than another and you're learning another language, you can transpile your code and then check to see how the transpiler wrote it to see why your code doesn't match the transpiled code and why maybe my Python script's not working, my JavaScript script is. I can transpile the JavaScript into Python and then look at the Python code, just as an example. So I do highly recommend it for everybody, and getting into the fundamentals of JavaScript programming language is also extremely useful. Especially with the documentation, which I had to refer to fix that problem I mentioned earlier, which we'll be getting into later on in this video. Hopefully it doesn't take me too long to get through all this, but so yeah, basically anybody can benefit from practice of breaking complex problems into manageable pieces, which can then be broken down into logical, functional, reusable components to find solutions and iron out some of that complexity. So abstractly, that's basically the mental exercise that extends far beyond just computers and technology, is that deconstruction of a complex problem and creating simple, more repeatable patterns of solutions towards that problem. So I don't intend these videos to be standard tutorials, though. As I've stated before, my aim is to show you another approach to learning to write code in general. So if you're like me, then all the training and free resources in the world are useless if the words in the tutorials are written in Greek and make learning a chore. So if the terminology is a barrier to entry, hopefully my videos will help make key terms and concepts more tangible to beginners, so that when you do look them up or see them in the documentation, you have some kind of mental frame of reference for how they're used and applied, and maybe that'll help you remember them, because that's what helped me. So in these videos, then, you're not going to be taught or told how to write good code. Instead, just how to notice how the JavaScript language allows you to be inventive. So more about the flexibility, because I found it incredibly hard to memorize all the terms and specific implementation details when learning to write code, and that proved seriously to delay the progress of my understanding and, trying to figure out why I could do one thing in my program but not another. It also made it hard to grasp key concepts like functions and loops, not realizing the practical use cases or benefits to those programming patterns while I was learning them. So it was only kind of later on that I realized how certain concepts were useful, long after I dumped a whole bunch of hours into painstakingly studying one word at a time from textbooks, blogs, or online documentation or whatever. So I just wanted to say these few words to mention that this series of training videos isn't going to teach you what you should do with code, but instead teach you what you can do with it. The flexibility of programming and practical uses for each technique we cover as we go along in this series is, in my opinion, the true value here. Unless web design is your thing and that's what you want to get out of it. But there are probably better training videos or tutorials or lessons or lectures or whatever you want to call it, talks. There are probably better resources than this to do the academic side of programming, but what I want to focus on is just making it relatable and approachable and something that you can just engage in Like immediately today while you're watching the video, you can follow along and not be too encumbered or overwhelmed by all these, juggling all these different files and applications and installs and yada, yada, yada. So yeah, to me, it's more important to get up and running so you can play and interact and build from ideas than it is to do things properly right from out the gate. But that's not to say there's no benefit to knowing how to do things properly and knowing the proper conventions and memorizing, data types and stuff like that. But there are so many great resources out there for that kind of stuff. So I'll leave that to the experts, and hopefully this video will help others, as I wish I had this type of resource when I was looking to program back before the days of YouTube. But so let's consider these coding sessions as sort of like the SpaceX approach to learning and programming, where you try a lot of things, break stuff, and test new ideas, the rapid development model, as opposed to the careful engineered NASA model. It's best to practice in the wild to use an IDE to help you write code, but honing your skill writing algorithms by hand is fantastic exercise, so that's how we're going to be doing it here. It's best to write code, efficient code in the wild, but it can mean it's harder to read and reason through errors if it performs some type of unexpected behaviors. So it's best to break functionality into separate files to keep your project organized and segregated, but it's harder for newbies to read code from a bunch of different places when trying to focus on the problem itself. And that's why I'm showing you examples which are contained all in one file, so that instead of a script file of code and a CSS file for styles and imported libraries and IDE extensions and live servers and blah, 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 blah. Instead of going through all the complicated mess, it's just one straight up file with the script embedded in it. And if there's styling or something, we want to make it look different, we'll just put that in the same page too. I think maybe the next episode we might be doing some style sheets just so that we can play around with active objects in upcoming talks and videos. But I'm getting ahead of myself. Where was I? Instead of best practices, I'm going to show you to play with code from one file, and you can run it on any browser or device that you have, and that's the easiest way to focus on one thing at a time rather than having a whole bunch of tools and options that don't even make sense to you until after you establish some type of core knowledge as a baseline. So for me, I wish I had learned to write code in this way, because memorizing is just dry and slow, and learning the basics by playing around with sketches and demos is way more engaging and responsive, and it makes learning more enjoyable and even more efficient, in my opinion. So instead of looking at learning like a right way or a wrong way, consider the value of learning things in different ways. Since all programming languages share many commonalities, there's a lot of insight to be gleaned from twisting code into something that's intentionally more convoluted than it needs to be, because it means that you'll get a deeper understanding of how the language and logic works by misusing it, quote unquote. That is, like, after frameworks like React became so useful to companies like Facebook and Netflix, and because JavaScript language was manhandled into new tools by the creative thinking of its engineers, it wasn't by doing what was already considered proper or right. It was from really bastardizing the original language into something that was even more functional and useful for the applications of the framework. So practicing creativity, I guess, with math is what we're after, and that bears fruit across all domains of knowledge, because it's like the refinement of craft in a particular language such as JavaScript doesn't necessarily need to be the goal. It's my philosophy anyway that learning to learn can be more valuable than a specific skill that you're learning. So hopefully that comes across in these videos. Let me just switch out here, and we will get started. Oops. So we'll start off the same way we did before. I'm just going to grab a random folder on my desktop, right-click the background, create a new document, and I'm going to call it something like methodlive.htm, because I was mixing my files up before. And I'm just going to keep plugging Sublime Text Editor because I didn't pay for it because it's free to use, but if you can afford to support the developer, please do. As an instead, I'm just going to plug them in my videos and hope that will suffice as payment. Because I don't use it, as I said, in my day-to-day. I use Sublime Text just for hand coding. I use an IDE when I'm doing regular development. And, let's switch to... I'll just drag this in here like I did before. And resize. So again, it's just a regular web browser, regular text editor. Nothing magic, nothing spectacular. Drag this file in here to make sure that it's reading from the right file. And then for Chrome, it's Control-Shift-I. If you're using Firefox or Safari or something, it's either Control-Shift-J or Control-Shift-K to pull up the console. And again, if you have something else in here, just check the tabs and switch over to console, because that's what we'll be working with for our code. And if x equals hello, and then I type x, we get back hello. There you go. Now you can see it. Great. So we're almost ready to start. What else do I need? I need some basic HTML stuff just so that we can start writing our script. So I've already got a template that I'm just going to copy and paste so you don't have to sit there and watch me type. There will be plenty of that later on. Oh, I need a script tag still. Script type equals text / JavaScript. And again, for most browsers it'll work even if you don't put in this type, but just in case somebody's using a setup different from me, which is probably going to be common since I'm on Linux and most people are not, we will start there. Actually, I guess before we start I should talk about what methods are and stuff so that we actually have some type of baseline. Let me see here. There we go. So, in our first episode, we dove straight into primitive recursion and recursive functions, which probably wasn't the smartest place to start, but I wasn't really sure that we were going to be continuing on with these extra bits, but I'm quite liking them. Hopefully you are too. We then backpedaled a bit in our following episode to build basic functions so that we actually have an understanding of how our recursive functions work, because we never really went over and covered the different ways of creating functions and what they're used for. So we demonstrated a few different ways and a few different types of variables availed to us by the JavaScript engine to show how flexible functions can be, since they accept as inputs any number of types. So like primitives, like booleans, so true or false. That's a primitive type. Standard integer, a regular number, a string of text. You remember those are wrapped within quotation marks. We even went over some higher order values like arrays and data objects. Functions are also considered objects in JavaScript, but I'm trying not to use the word object because it's used synonymously in the language with another form of object, so it's not kind of confusing, it's really confusing. There's the data type object, which is a variable that stores a bunch of key value pairs, and there are objects, which are just like an array is an object, a string of text is an object, a function is an object. Everything's an object in JavaScript, which you've probably heard many times before if you've ever looked into beginner JavaScript programming. So I'm going to try to avoid it whenever possible, but the data type object is impossible to avoid if I'm trying to explain how to build a data type object. So I'm going to have to use it, but just make a mental note, maybe not to think too hard about the word object, because it's going to be used in confusing terms and in different situations. So if it's confusing, it's not you, it's me. So we're going to talk about methods today, and a method is just a function. That's it. It's the same as the other functions we've done before, But let's say we want to create a variable that holds many variables. We call that an array or a list, same thing. So a person, for example, has many properties, or in other words, describing pieces of data. A person has like an age, a first name, a last name, a height, etc. So you don't want these all to just be separate variables somewhere, because you want to be able to store them in a logical sense. You want to know a specific person's first and last name, and you want to know the age of a person who contains the first name and last name of whatever the person's name is. So keeping all those pieces of information separate, but we want to bundle them together to make it easier to move them around and actually draw the values that we're trying to get. Like if I'm trying to get my age, it doesn't really make sense or help at all to have an age variable that just stores every person on Earth's age, because I wouldn't know which one is mine, right? You want to sort of associate it with a specific piece of data. So arrays are ordered lists and objects are unordered lists. In the form of the data type that we're speaking of now. So you can remember the arrays are listed out as being indexed, and the index starts at 0. So the first item in the list, right at the top of the list, is 0, and everything after that is just an integer value, 1 above for every element in the array. For object data types, we use keys instead of indexes. So in the example that I gave you with a person's first name and last name, in the example I gave you of a person's first name and last name, the key would be first name, and you might want to apply that key to a whole bunch of different persons so that you could compare them really easily. But you want the values to be different between people, because each individual person may have the same birthday or, age and first name or last name. But you really want to separate them into a separate data object in order to be able to track them, manipulate them, move them around, and just for usability, they need to be attached to something. And that something that we're attaching it to is just a variable name, and that variable name is just a type of a data type object or a data type array. So we can store the details as another example of a point. So a point may have coordinate space of like x, y, and z, or z in Canada here. You can store the details of a point in an array and just make a mental note of which index is for the x value, which index is for the y value, which index is for the z value. That's one way of doing it. But let's say we also wanted to add like a color value to a point. We could then do that by adding an array of red, green, blue RGB value to the array that contains the coordinates. So then we'd have index 0 would be x, index 1 would be y, index 2 would be z, and index 3 would be another array embedded inside of that array that gives us the color value for this example. The easier way to lexically talk about it or keep in mind which indexes do what, we could use a data type of object that just gives us keys, and the key could be, let's say, x. So point A would be its own variable, and it would contain all the x, y, z coordinates. And the key value of x might be assigned to the x coordinate, the key value of y might be assigned to the y coordinate, the key value of z might be assigned to the z coordinate. Just as an example of how we can speak through the code and understand what we're looking at. So let's now say that we want to perform an action using the information contained in our array of points and its color. We can just as easily assign a function to another array or object value. So instead of just having x, y, z, and our color, we could have another index that has a function inside of it, just like we passed functions around in the previous two videos that we did. So this is what we'll be covering today. So a method is just a function that's tied to a variable to act or do something whenever we call it. And the reason why a method is has its own word or phrasing or verbiage is because it's specifically tied to a variable that contains other data usually, and that function applies to all the data within that array, as opposed to a function that just does everything globally. So you can remember our add function. You just stick a number in and it adds them together. But if you wanted to change like an X and a Y coordinate space for just one point, and you've got many, many points, like particles or something, you might want to apply a method that only applies to that specific point, and you can call that just by pulling up the index or the key of the data object, whether it's an array or an object, and you can call it that way, and it's tied directly to the thing that it's going to be changing. And that's very useful in just helping organize code and keeping a mental track of what we're doing to what and where and why and all that. We can call it the same way as other functions, except for one thing. You need to call it by using the array or object name first, since the function is defined as part of the array or the object, not just standing on its own out in the ether. So the reason it's not standing alone, as we alluded to, is that this method is it's going to use the other elements in the array as part of its action. So it's very specific to that one singular object. And that's just to give you sort of a mental idea of what we're going to be doing in this video, but instead of getting ahead of ourselves, maybe I'll just start by making some arrays and objects, and we can build some functions that help us build arrays and objects. And using functions to build uniform arrays and objects is pretty similar to the concept of classes, so maybe I'll cover classes too. Yeah, let's do that. And then at the end, after we go through all that, we'll check out the built-in functions with JavaScript language, and the ones that come right out of the box. More specifically, we'll talk about the sort function, because that's where I got myself tripped up in the end of the last episode, because the console was logging a mutation of the original array, but also all of the indirect references I made to it after the fact, which I wasn't expecting, but I should have, but I wasn't, because it's complicated. But at the end, we'll cover that complication and the sort method and classes, objects, arrays. Yeah, that should be plenty for one episode, I would imagine. Okay, so I'm just going to move my head out of the way. Like before, oops, there you go. Like before, we just created a new file, threw it in here. I had a little template thing going so we didn't have to write all this stuff ourselves, and now we're ready to go already, just with our script tag, and all of our JavaScript can be contained inside of our script tag. So I'm going to create a new array here, and I'm just going to give it some number values to start us off with, so that we can get used to just creating new objects and playing around with them, breaking stuff, basically. We're going to make a second one, just so we have some text to play with too. I'm going to very creatively name these based on their indexes in the array, but again, you can obviously choose whatever you'd like to name all these things. One more, why not? Now, if I console log array A and array B, just to get us started here. Now remember, the drop downs, the little arrows here on the side will let us expand and see what's inside of all our arrays, and it'll also list them off by indexes, which is really handy. So I use these a lot. If you want to look up other methods within the array prototype, you can check the prototype here and take any number one of these and just look it up, do a quick Google search, and you'll get all the documentation and implementation details that you can possibly stomach that way. But that's really dry, not that it's not useful, but there are other videos that will definitely do that a lot better than this one. So we will skip that bit and just play around a little bit with some basic methods that we have. And, well, I guess to start, we should start, how do you call something, right? If what's the point in storing a value if you can't pull out that value and tell it, what you want? So let's just take the first index of both. And remember, indexes of arrays always start at 0. They're just numbered lists. There you go. So the first value here is 15, and the second value here is text 0, and that's because we got We got index 0 from array A and index 0 from array B. Our console log, I just wrote it out a little bit differently to show you, again, the flexibility of anything within parentheses we can kind of play around with, and anything inside of brackets we can kind of play around with. And I'll show you some examples of that. So this is very similar to any function call. Log is actually just a method built onto console, which is a built-in of the JavaScript language to tell it to communicate with the browser console, which is why we open the browser console to read all of this stuff. Makes sense, but to say it out loud kind of like points out that it makes sense, I guess, for lack of a better term. Before we get into methods and stuff, maybe we should talk about objects too. I'm just trying to think of the best approach. Well, let's start with indexes, because there's something important to notice here. When I'm pulling up array A and I'm giving it an index, I can actually give it a string index, and it will interpret the string as a number because it's expecting a number. And JavaScript, that's what we were saying before, it's flexibility. That's also the bane of its existence because it can create problems by mutating itself to other data types without producing an error. So you'd think that more errors would be bad, but more errors is actually easier to debug because it tells you exactly where your code is failing or not performing the way you expected it to. But in our case, I'm going to show you an example of how this can get a little bit confusing. So you'll notice that when I put in array A and I put in the string, not the number of 2, the indexes are sorted by numbers, but I put in the string of 2, that's 0, 1, 2. It's going to give me the 55 anyway, because it knows it's expecting a number and it can convert this easily to numbers, no problem. Another thing that you can do is choose by adding, you can do mathematical operations in here. Oh, I guess we don't have 5. So 2 plus 1. Instead of giving us 2 or 1, what it's going to do is it's going to evaluate what's in these brackets, which in this case is 3, and then it'll just pop out our third index, which is 0, 1, 2, 3. It's actually our fourth index is index number 3. And if we save that and go back to our browser, you'll see that 1 is the value we get, and 1 is our fourth item in our array, which is index 3. Now the weird thing is, if you do a string, this is going to convert everything inside of it to a string, because it's not going to go from string to number and back to string, or from number to string to number, or whatever. It's just going to evaluate it based on one hierarchy, and numbers are lower on the hierarchy than strings. So once you've converted a number to a string type, it's just going to stay a string type. So this is literally the same thing as this, but in JavaScript, because of that flexibility, like we discussed, it doesn't actually say anything, and it's going to return undefined. So you might say, well, why? If 2 plus 1 gives us a value that's accurate, why wouldn't 2 plus 1, or even still 2 plus 1? And the reason for that is it's giving us as an output, let's just say console.log 2 plus 1. Let's see what exactly it is that we're putting inside of our array index finder thingy. You'll see it comes back as a value of 21, and that's the same as a string being added to a string. So it's not doing the mathematical operation of 2 plus 1. It is doing the string concatenation of adding the string 2 to another value, which just in this case happens to be 1. Maybe for clearer context, since the value is also 1, we'll say 2. Now, this can be useful because it can allow you to juggle around things like text strings and easily convert them without having to run through a convoluted process of converting things back and forth to different data types, or, writing a bunch of functions. You could just simply write it in here. And in your use case, that might be practical and helpful, but it can also be a source of sorrow, for lack of a better term. Because as you'll see, actually we haven't introduced you any loops, so I'm going to write a for loop here for you just to demonstrate. So a for loop is just a reserved function for the programming language that's going to loop a certain number of times. And the way we tell it how many times to loop is just by creating a variable, let I, well, I is less than 50, and then we're going to tell I to increment. Plus plus just means I equals itself plus 1. I guess, in other words, we can actually just write I plus 1 for this demonstration. So the for takes 3 always. It takes 3 different statements. The first statement is to define whatever variable you're going to use as a counter. A lot of people just use I because I stands for iterator. It's just a placeholder basically, but I guess in this example, since we haven't done loops yet, I don't think, I'll name this all counter just to make that exactly abundantly clear. Counter equals itself plus 1. And then you open and close curly braces just like any other function does, and whatever you write inside of this function is going to loop every time that iterator runs through. So if we want to see what's in there, we'll just say console.log I. No, we didn't call it I, we called it counter. Oh, there we go. So now when I refresh, you'll notice that on line 25, which is our line right here, it is telling us every single iteration, every time it runs through this loop, it's going to console out the value of the loop. And you'll notice once it gets down to 49, because counter 49 is less than 50, but once it gets to 50, it stops running through this loop. So we don't see the console log counter at 50. Now, the interesting thing about this is, going back to our array example, if I add, using an array method called push, if I add counter, whatever the value of this counter is every time it goes through that loop, and remember it goes through the loop 50 times, it's going to apply the method push to the array. And every array gets this push method. It's built into the language. It's one of the most useful things you could possibly come up with, and saves us having to write a whole bunch of code. So you'll be using this one a lot, best to memorize it if you can, but this dot notation means that the push is a function that's contained within the array. And the reason why we want to do this is because the push function, we want it to apply directly and specifically to this data object. We don't want it to apply to anything else outside of this array. We just want to push a value onto the array, and which array is it? Well, it's the one that we're calling the method from. Throwing counter in there is just a way to give it a different value. So we're not, I mean, technically you could just, give it a test value or something like that, but that's going to be, see, when we go into our console here, oh, we don't have an array C, right? Array A. Notice it just gives us a whole bunch of test values, and that's not very helpful. But if we go back to our counter example, now you'll notice when I hit console.log the array A, and I use that 2 plus 1 again, notice that it's going to give us back the string of 2 plus 1, which is 21, not the actual math of 2 plus 1, which would be 3. It's going to put that 21 into this index finder, and it's going to try and match up 21. Index 21 does exist now because we used our loop to add a new element 50 times to that same array. So now when we console log this out, assuming there are no errors, actually, I'm going to detach this just to make it simple. There we go. Alt-tab. Sorry, I'm just going to resize my windows a bit here so I can see all my line numbers. So you'll notice now, when I call this line 29, which is our console log, that string of 2 plus 1, that it pulls up 14. And the reason it pulls up 14 is because 14 is the exact same. If you look in here and check, and we hit that little drop-down key on our array and look at all of our index values, if we go down to 21, you'll see that's the value of index 21, is 14. So just be conscious of what data type you're putting in here if you want to do some math to something. If you're trying to say array.length, length is a property that applies to all objects, so you can give length to anything. but the length is going to be an absolute value of all the number of elements that are contained inside the array, so it's just basically counting all of these, 1, 2, 3. So if you do, because the indexes start at 0, the length is always going to be 1 more than the index of the last item in the array. So in other words, if you were trying to, say, count down from the end of the array and back down to the beginning of the array, you would want to start by saying, well, whatever my length is, do that minus 1, and use that as the index for the array, because I'm trying to find the last value in the array. For example, the length property will also work with object data types, which we'll see in just a minute. And I'm going to console log this stuff out so it's not in our way anymore. Actually, I might want to keep one of these just so we have some kind of output. But I don't need this one because that's making a huge mess. And I don't need that one because that is polluting my memory. I'm creating a whole bunch of data fields that we don't need. So all that to say that we have ordered lists, and we can call our ordered lists and get the values by pulling up the index of those ordered lists, and we can apply methods that are built into the programming language, which are functions that apply directly to our lists so that we can fiddle with them and manipulate them and see what the values are actually stored, because there's no point storing values if you're not going to use them and put them to practice. So let's get into objects then. So we know we can create an array by simply just opening and closing square brackets here. To create an object, it's very much the same, but you use the curly braces for it. Now, the difference between this and a function, the curly braces that we use inside of a function or outside of a loop, in other words, this is essentially the same format as a function that takes 3 arguments. Pretty much the same. These are basically functions as arguments, no different from the functions that we wrote before, and for is like a built-in function, basically. These curly braces, when assigned directly from an equal sign, are going to be key value pairs. So instead of having an index number that's ordered, we have an unordered list, but we can create, let's give this actually a proper name. We'll call it a normal object. We can create the keys for it instead of having just indexes and having to memorize which index is for which value. So in the instance of our XYZ coordinate system from before, remember we had said either maybe every time we reference a point, it's got the 0 index is the X value, for example. But sometimes it's not helpful because then you have to find a table to look up like which index is which value for this object. So it's much easier to just name them in plain English, and that's what objects do. So here we have an object where the key is the first part, separated by a colon, and then the value is the second part. So this entire thing could be a function too. This can be anything we want. So let's just make a quick arrow function to demonstrate. So this is a function that just returns a string. That's all it does. And the string is the value of first name. So if I want to check out my object, I can console.log normal object dot first name. So the dot is basically telling us, sorry, I lost my cursor there. The dot is just telling us which part of the object that we want to look at. And now that's going to tell us, that's because we did not execute it. So, bad example. You can throw a function in there, but it's not producing the output I was expecting, and that's exactly why I like doing these types of code exercises, because I always come up with ideas that like, oh, I wonder if I can do that, and then you just console log it and try it, and if it doesn't work, it doesn't work. So you can throw functions in there, but we'd have to get too complicated in the example, and I don't want to sort of like deviate and like how to. Okay, so what we're doing is we're just calling this normal object, and instead of getting all of the items in it like this, we're basically just calling the index that we want, but instead of having a numbered index, we can name the index whatever we want, and in this case we named it first name. So in keeping with this, I might so last name Gravitas, and let's do an age too, so that now you notice I'm not really being terribly consistent with this, but this is a number type because I'm not wrapping it in quotation marks. This is because it's a key. The key is going to assign itself as a variable as part of the object, so you technically don't need to add the quotation marks, but just for browser compatibility and for things we're going to be doing later on, definitely best to just throw that in there. Well, I guess I should show you that it works first. Last name Gravitas. So I'm going to wrap them in quotes just for consistency's sake, but just so you know, you don't have to. And again, if we console log just the object without the property or the key listed specifically, it's just going to give us the whole object, and then we're going to be able to like break it apart like we did before. Note though, these are technically unordered, so sometimes they might come out in alphabetical order or something, but intrinsically to the object itself, the difference between an array and an object is the object has keys instead of indexes, and the indexes are there to order things, as we see here. But objects are unordered things, and they are named things, which makes them very helpful. So to move this along maybe a little bit, let's give you some examples of how you can nest objects inside of objects. So you can have an array as an element inside of an array, and you can have an object inside of another object. So if we say we'll say food because everybody likes food. We're going to call it some apples, some onions, and some chicken. Now notice if I wanted to make a variable chicken text food like this, I could just as easily put my variable in here, and it will resolve itself when I call ingredients. No, I want ingredients. That's what I said. So you'll notice that when I built this array here, that's line 35 down here, I built using a variable which I defined up here, and it assigns it, no problem, in order. 0, 1, 2 is our indexes. We can also say, because all arrays have a length property, we can also check the length of it, which is 3. So keeping in mind what we can do for one thing, we can do for another, as long as the objects are the objects, everything's consistent throughout. But what we want to get into is nesting data objects inside of other data objects. So to do that, I'm going to give the example of some cooking instructions. So we'll say like first step is to apply oil, and then we want to mix ingredients together. And notice these are just string objects, and we're separating them by commas. So each one of these is going to be another value in our array, and we know it's an array because we're using these square brackets here, as opposed to the curly brackets, curly braces, that give us the object. And let's give it one more. So remove from heat after 10 minutes. Now, if I were to make an object that consisted of arrays inside of object keys, that would be considered a nested array, or something, or a variable with depth, in other words. I'm going to use a lot of different terms to sort of describe it, just to help you wrap your brain around what it is exactly we're doing here with our little our JavaScript gymnastics. So let's say our first, remember they're separated by keys and values first by a colon. So our first one, food, is going to be ingredients, and that's the array of ingredients we put up here. I'm going to make that whole array as part of our food index. And we should get a second index here, like instructions or something like that. Yeah, sure, instructions. And oh, that might be confusing because that's the variable name we chose. So best to choose good names, but when you're practicing and just playing with code, it's not as important, so you'll see me breaking conventions a lot in that respect. But in order to see it, as I tried to refresh our page, we need to console log that too. And here you'll notice that inside of my object of baked chicken recipe, I have a food index, which is another nested array. And I have a guide, which is another array that we made of instructions to cooking that recipe. So this baked chicken recipe is an object. This thing contains this key, and that key is equal to this value, and this value is equal to this array. And that's one of the most powerful things you can do with lists and objects is compartmentalize not just values, but also functions and utilities or tools or things, actions that you want to perform. And that's what a method is. A method is like assigning a function to one of these keys. And we're going to do that. I tried recording this before and my face was in the way, so let me just make sure that monitor only. There we go. That'll be easier. Okay, so let's get into some methods actually. So we'll get sorted ingredients, let's say. Oh, let's actually use another notation. These calling an object with the square brackets, even though you use the curly braces to define an object, as we did up here, you can also get the values from them without using the dot notation if you want to use these square brackets. So you might say, well, what's the point if I can just say recipe dot food? Isn't that like 10 times easier? And you'd be right in most cases, but. If you'd like, you can put a variable name in here. So let's say let idx variable equal, I'm going to use the word food. And instead of actually putting in explicitly the key that I want to enter, I can dynamically figure that out using some other function or some other piece of my code written somewhere else. And I can then pull up values just based on programmatic intentions, as opposed to explicitly declaring exactly what item I want to pull out. And that's really handy. There you go. Oh, syntax error identifier. Line 41. IDX variable. IDX variable is food. Baked chicken recipe. Yeah, I didn't think that was the problem. So, where is our error? Instructions, ingredients. There we go. Sorted ingredients. I had a space in my variable name and that made everything not work. So now we're good. So you'll notice now when I hit line 42, this one here. Oh, sorted ingredients is what I'm looking for, not baked chicken. See, I'm already getting ahead. So it is sorting ingredients, and you'll notice this little I here, as we were discussing in the past video, that this was evaluated upon first expanding and it may have changed since then. That's where the sort method really took me for a loop, pun intended. Actually, maybe I'll explain that just a little later. Yeah, let's talk about methods first. Like, we'll talk about the simple ones, the ones that aren't causing problems. Console log. I'll just remove some of these logs to clear up our console. There we go. So we're starting fresh. Now, so one of the most effective methods that you can apply to arrays is the filter method. I'm just going to quickly make a variable here based on the output of a filter method so that you can see what it does. And I'm going to use, I'll use the guide variable here. So just like we do with all methods, dot notation. So I'm taking the variable, not just the object of this, but actually the array that is from the guide key from inside of my object. So this guide key here, this recipe object is containing food and guide contains this as a value, and this value itself is the array from this block to this block here. So it's got 1, 2, 3, 4 elements inside of the array. So what I'm doing is I'm taking the baked chicken object, I'm taking the array that's labeled from the guide key, and I'm going to filter that and see what I can get from it. So filter takes a function, and we know arrow functions now because we've been playing with them. And as part of the filter method, it gives you a parameter just off the hop. So whatever you name this doesn't matter. You can call this whatever you want. And just to space things out, I'm going to hit enter, and my text editor is going to change all this, but just keep in mind that this parentheses is still within this filter call, and all I'm doing is giving a function inside of that filter call, which is this block here. Now, what do I want to filter for? Let's use another method to help us do our filter. So I'll start with an if statement, and again, anything inside the parentheses is what our if statement checks for as a true or false. So I'll say if, and we'll use the includes method, yeah. So this whatever you want is the same as, well, I guess I could write it here, but it's just going to be a lot of typing to keep using the same thing over and over again. So usually you'll just set this as X or whatever, but for this example, I'll use it. So I'm saying whatever the current item is, because this filter method goes through every single item of the array, because remember, filter is a function that applies to arrays, and guide is the value, or is a key that links to an array that's stored within the object baked chicken recipe. So what I'm doing here is I'm going through this array of instructions, and then I'm going to filter out, and what filter does is say, hey, here's a function, and give me a true or false of whether or not to include this value in the function. So I'm going to give it a condition, and that condition is, let's say if it includes, well, we'll just say if it includes the word preheat. Oops. So if it includes the word preheat, it's going to return true. And this is sort of a, there's much shorter ways of typing this, but I'm just trying to show you the functionality of the filter method. So filter takes a function, and that function is guaranteed to give it at least one argument, and that argument is whatever the current value is that it's going through. So in this case, the instructions is this array here. So whatever you want in the first case will be preheat the pan. The second time it goes through the filter, it'll be apply oil, etc. So if preheat is included, which is another method, if this array includes a value that has this as at least part of its response, which the first index does, but none of the other ones do. The other ones have actually this one has heat, so maybe I'll say preheat. That way we'll get two things back, and you'll get a better idea of what the sort does. Anything that returns false, again, we can say it explicitly, but we really don't have to. This is just being redundant. We'll say otherwise return false. And if I console log that out, you will see that we will get a filtered response. Oh, typo. Baked. The D. typo. Whatever you want .include is not a function, because S includes is the method. There we go. So you'll see it returns an array, but it only returns the elements that have the word heat in it. If I didn't put, if I just put preheat like I had originally, it would only show me one, because only one thing includes the word preheat. But if I shorten it, I'll get all instances of heat, even if it's contained within the word. It'll still return true because it's contained at some point somewhere in the value of that index. So filter is a really handy method to get used to. Primarily because it takes in a function, and we've played a lot with functions and passing functions into functions lately, so this is a practical use case of when you pass a function into another function. In this case, we're passing a function into a method, and if you'd like, you can say let compare method. Actually, I'm just going to take all of this from here, which is the end of my function. Cut. So what I'm doing is I'm making a function called compare method, and instead of writing the function inside of these brackets here, I'm just going to call it from here. Notice they'll both do the same thing, but this is cleaner to read, because if you're reading through and you want to say, well, what's preheat equal? Oh, it equals this. It equals the value of the index at this index, and then I'm filtering it for what? Compare method. If you ever want to double check what compare method is, let's say it's, you know, you've got long code and it's way up here, way down there, whatever. This is a quicker, shorter way of just making a reference to it. Rather than having your code written directly inside of the method that's calling. They do the same thing. There's no wrong way of doing that. Usually if you have something really simple and quick and easy, then you'll write it in the way I'm doing here. And if it's long and complicated, your comparison, you'll probably want to separate it just for readability's sake, not because it won't work otherwise. But so that's the, oh, we should label that. Call that the filter method, because that's what it's called. So the filter method is going to iterate through all items in the array, and it'll check the function returns true or false, and then you can create a true or false condition based on whatever element the current element is through the loop, and it works just like our for did up there. Except in this case, we were specifically saying run 50 because you start at 0, and as long as you're less than 0, then keep increasing it by 1. In this case, it's just going to say, if there's an element we haven't checked yet, check it. If there's an element we haven't checked yet, check it. And the filter will just go through all elements in this array, no matter how many you have. My favorite and most used method actually is the for each. So I'm just going to call this one each equals. It's called bake chicken, baked chicken recipe. Food, I think we called it. What do we call it? Yeah. Okay, so ingredients is this, and that's a list of 3 items. It's the for each method, again with the dot notation, and you can apply this dot to any normal array. Even these arrays up here, let RA, you can do that. We'll just use B, we keep using A for each. Same thing. But in this case, I'm not sure if we went through these before. These give us a value, the index, and the original array, and that's just in case you need them. You don't need to use them all, then don't write them in. I'm just going to put them in for comment's sake, just so that you can see that they're there. This, unlike filter, it'll do something once for each item that there is an array, but you don't necessarily have to do something to this array. You can simply, let's say, console log it if you want to display it. Sorry, I'm kind of writing lopsided so that I can face the microphone. I was getting some audio issues before from talking and looking away. And just like we did, hold on, we'll comment that out for a minute. And just like we did before with our for statement, where we were looping through every number, we can do the same with like items and arrays. So this is literally the exact same thing as saying like for let I equals 0, and then rb.length minus 1. Then we want to say, well, I is less than, I guess we don't need the minus 1, then I plus. And I'm just going to console log out the current index that we're at. And now we're doing the same loop as before, but we're doing it based on the actual length of the array that we're looking at. And then I'm going to use this I variable inside of my loop to denote the index that we're looking at. And from that index, we're going to get a value that is one of these four from our array, assuming everything works fine. So you'll see they do the exact same thing, and that's sort of the point of these methods, is to get something done with a lot less work. Instead of having to type all of this out, I can just enter in a for each comment that has all the values that I'm looking for without having to state it explicitly like I did here. See, so for every iteration, it's going to give me the value of that iteration. It's going to give me the index number. So if I want to use this to, say, refer to another array that has matching indexes, for example, you can do that too. Or you can do that from within here. Like, there. I'll show you another example. We can say array index, and this is so redundant, but what I'm doing is I'm taking in the third argument from the for each method, which by the documentation, if you look it up, it tells you that it gives you a value, an index, an array, which I summarize usually to just via to help me remember it. And I'm going to console log out the original array, which is one of the arguments that it gives me for my function that I pass into my for each method. I'm going to use the index that it gives me too, and I'm going to see, is that equal to my value? So instead now of printing something specific like a value, what I'm going to do is, because I'm using, well, we'll make it simple. I don't want to get into the operands and stuff, but this array index is going to equal the exact same thing as our value here. But what I'm doing in this console.log is I'm giving it a true or false expression. So that's another way of using console.log, another way of showing you what automatic values are passed into the function that we're passing into our method, which is attached to our array. It's a lot to dig in, I know, but you'll get used to it. The dot notation basically just states that any item from within either an object, and an array is an object that does have methods attached to it, but its values are indexed, and that's the difference between arrays and objects, is that indexing. So there's like substrings, there's all kinds of different methods. I guess we can kind of look those up too. So JavaScript array methods. And you'll see if, hold on. You'll see in the documentation, which you can look up absolutely anywhere, all kinds of different methods that you can apply to strings, numbers, objects. I think even Booleans probably have. I wonder. Boolean methods, JavaScript. Yeah, cool. Boolean's even got some methods. Not many, but there's type of, there's call, there's bind, apply. So yeah, you can look these up. Documentation's super helpful, especially W3 schools, because they show you examples and they let you like try the code out yourself. But we won't get into that, just for the sake of brevity. So moving on. I think, well, let me just comment some of this out. Yeah. Okay, let's give ourselves some more space here. And we'll start playing with some more stuff. So one of the most important ones, let's see, array D, 774. I'm just using some random numbers here to give us another array to work with. Some of the important methods that we covered before is the push method to add stuff onto, add it on the end. And let's console log that so we can see what we're working with. Remember, I commented all this out so it cleared our screen a little bit, so if yours looks different, that's why. Notice at the end of our array, no matter how long it is, using the push will add another element to the end of our array. But what if we want to take it off? Well, the method pop does that for us. But not only does it take off the last value at the end, it also returns it. So if you want to assign something to the last value at the end, so let last value of array equal So instead here I'm going to create a variable, and again, no spaces, but you can use the underscores if you really want to make your variables explicit. That's the best way to do it. Another method is just Camelcase, which is capitalizing the first letter of every other word. Makes it a little bit easier to read. But this pop method applied to the array D not only gives you the last value from the array, in this case it's this because we added on at the end, that string of text. We added that to after the last element of the RD. So when we pop it, it's actually removing it though from the original. And that's important to note because some methods change the original array and other methods like filter don't. And that's where I came into trouble when using that sort method, because sort is one of those methods that does that. So you'll notice the first time we call it here on line 63, after we've added this by using the push method to our array, so again that's just our array, dot notation, and then the function push. When we console log it, we actually get the item added on at the end. But after we pop it, after we call the pop method to it, the array is changed. It's mutated after the fact. And that's perfect when you expect that behavior, but when you don't expect it, it can become problematic because then your array and all its references will also be permanently changed. So let's talk about like data objects, I guess, because one of the ones that I use really often is for arguments, and I need a function for this, so I gotta be inside of a function, and we'll call this the many arguments function. So what I'm going to do here is I'm going to create a function that takes as many arguments as possible. And again, should I give you for example? Many arguments. So after I define the function, the inputs that I give it, these things here, separated by commas. If I want to give as many of these as possible and be able to run through them, the way we're going to do that is through an array. Now, one of the built-in keywords is arguments, and you'll see that in my text editor it actually changes colors because of that. But I can say args equals array with a capital A, because that's the data object. This is the built-in from JavaScript that we're using. And the from method creates an array out of whatever you put inside of the from method. So now if arguments equals this collection, which is a keyword collection, which is similar to an array, but it's not exactly an array, but I want to make an array out of it, I'm going to create a variable that's built out of this collection or set, or I'm not sure exactly what it is, but I guess I can check. Arguments And let's also check what type it is. So type of arguments. Not always useful because in JavaScript this type of usually just returns an object because everything's technically an object. So you'll see, yeah, it's just going to give us object. Doesn't tell us too much. But what it does tell us when you go into these drop-down lists is that it's a symbol iterator. That's what it's called. So it has a length, just like anything else, but the length comes back as 0 because I didn't put anything in it. Let's just create some values. Create some values 10, and we'll use a real number 42. So now it's got a proper length of 5. It's got indexes just like a normal array, so that when we create an array out of this, we actually get something useful. And just to compare and contrast, I will use my my variable here, which the array that I created out of our arguments keyword object here, our collection, and now you can tell the difference. This one's got like a callee, it's got symbol type iterators and a bunch of weird prototype objects, and this is just a standard array. And our array gives us all the methods that we come to know. Fill, well, we didn't use fill yet, but filter. And again, filter is a method that's tied to all arrays. It's part of the prototype of array, and you can just look those up on Google and get a lot of detailed information like we checked in here. The W3 school stuff. So yeah, that stuff really handy while you're learning. And it's got examples and everything else. Everything you could possibly need. So methods are very, very useful, as you can come to see, that they not only help us manipulate arrays, but they help us track and update them and change them. So we've got object. We didn't do nested arrays very much. Let me get rid of this here. Or actually, I'm going to keep some of that. Yeah, let's get rid of that. So let's say we're going to say we're going to make a nested array. And what's a nested array? It's a regular array like this. Item 1, block 1. And again, this can be anything you want. It's just for comparison's sake. Now, what if I took this element here, the next element that I add in, let's say I make another array, and this array is just 5, 3, 4. This nest y now equals an array, and the last element of the array is another array. And this is very much like matrices or embedding tables or any type of data science that you're used to. Like a two-dimensional data structure is just a table. It's got x and y coordinates. A graph is just a table. It's all the same. You can do that with arrays by just embedding an array inside of an array. And this is very common, especially in like computer graphics and things like that, for coordinate systems and points and vertices and rotations and skews and transforms and translations and anything you can think of in Euclidean geometry. That's what it's doing. It's just nesting lists inside of lists inside of lists, and it's doing dot products and cross products and all kinds of math. But one of the neat things you can do with JavaScript is that you can tie methods into each other. So like, I'll just give you an example first to start. So nest y. I'm going to console log the original, and then I'm going to start popping stuff off of it and see what we get. So the return of this, remember, is the last value in the array. But you can add another method to it because you can apply the pop returns this whole thing, not just one item, but this is element 0, element 1, index 2, element 3 or index 3, right? If I apply another pop to that output is this array, and every array can get a pop method applied to it, and it just removes the last value in the array. That's what the function does, right? And then if I console log it again, you'll notice that it's not only been changed, it'll be missing that last item, but it's also going to be returning the number 4 because that's the last item on the for array, assuming I got my brain logic working. No, oh, I didn't define y. Nest y, that's why. Nesty. So, this is sort of the neat thing about JavaScript, is how flexible it is with, I think it's called currying. When you add one method to create an output that feeds into another method. We do this a lot with our functions too. It makes your code really hard to read and spaghettified and stuff like that. But when you're just doing common boilerplate stuff that you do all the time, like let's say you're linking to a server or something and you just want to put it all on one line, it's got that flexibility and capability to just to tie one function into the next function and chain them together like that, or currying functions together. And when we're talking about functions that are applied to objects, we just call them methods, but you can think of them exactly the same thing. Let's use, yeah, I'm going to use y, but I'm going to use a more complicated example just for the sake of instruction. So what happens when, oops, and just to save you from having to watch me type it all out. So this is nothing different from what we did before, but I'm just embedding a bunch of arrays into arrays. So this time, y is 1, 2, 3 is the first element, ABC is the second element, and the third element is all of this. And within that third element, I have another array, and another array, and another array. So now, when I run console log on y, and then I'm going to pop it 3 times. The expected result is you first look at the opening brackets and say, okay, the last element in this array, that's this one. The next dot pop is going to pop off from that last element, which is this bundle of 3. That array there is then going to be fed into the next pop call, which is going to be our last value of our last array in our last element of our main array. So if that's not confusing enough for you, oh, identifier T has already been declared, right? Because I'm reusing variable names. Let's try that again. You'll notice 12 pops out at line 74 after a bunch of convoluted work. Now again, this is absolutely something you should never do. But knowing that you can do it and playing with the language that way helps you really understand what the engine's doing in the background or underneath. Now this leads us to where the major problem is that I came to with the sort method before. Because what I was doing, let me just comment all this out. Okay, with the sort method, what I was doing before is I was trying to assign the value of an array to a separate variable and then change the original and then have the one that I've assigned separately. I was trying to have them not be correlated, so saving it for later in its original use case. But it wasn't working because the sort method doesn't just change the original array. In JavaScript, it actually updates the value of the original array, which makes it even more complicated to manage, like, mentally in your head. Maybe it'll be easier to explain with a little bit of visual aid here. Okay, so I'm going to just start with an example. So 3, I don't know, 521. Let test1 equal example1, no spaces, and equals, let test2 equal example1, and let test3. So what I'm doing is I'm just going to set up a case to show you, actually I'll do test3 later, to show you what the issue is, just like in premise. So when I console log test1, remember test1 and test2 are both equal to the same array, right? So we should be getting exactly the same, nothing crazy to start with at least. And as you'll see, we'll get the same array twice. Okay. Now, if I change that by calling the pop method, and then I console log it again, we get the expected behavior. Both our test1, test2 are the same. They both they give us the 4 elements, which we expected because we didn't call pop until after these two console.logs are run, and pop will just remove the last element, right? And then once we console log it again, we'll notice that that reference has changed it to remove the I, or the 1 I mean. And you'll see from this little identification thing that this value is evaluated after expanding blah blah blah. Now, the issue is I didn't do anything to test1 or test2, but test1 changed when I changed example pop. And this is really confusing, not just because of the path of logic here, but if you think about it, your code's supposed to be running from top to bottom. Then if this equals that and that equals that, changing example after I've set test shouldn't affect test1, but it does. And that's just the programming language specific. And that's what tripped me up last time on our other video. Now, to fix this, this is what's called a shallow copy. To fix this, there are a couple ways of doing it. You can do a shallow copy, but that won't change any of the embedded arrays inside of it. In other words, like we did up here, where was that? Yeah, right here. Copy. Paste. Any of these embedded arrays aren't going to get copied when we do a shallow copy, and that makes things really complicated to track because, as you can see, it's really common to have lists of lists. Like if you think of your grocery list, you might have like a list of things to buy for your spaghetti. So you might have like onions and sauce, but you might also have something for your dinner party next week that you want, like you need flour to make dough, and you want to keep those lists separate, but they're both on your shopping list. So your shopping list might consist of a spaghetti list and a desserts list for next week, and then household cleaning supplies might be a separate list, but they're all contained on the same shopping list, but you can see how there would be sub-lists inside of those lists. Now, when I'm assigning it this way, all I'm saying is that the value is equal to this example. It's a reference. It's a pointer to example. So every time I call test1, it's calling the pointer to example, and example has been altered since I assigned it. And that's where the confusion comes in, because you would one might assume, what I would assume is that when I set something as value, I should just say this is now the value of test1, but that's not accurate. What I'm saying is test1 is equal to the variable example1. And when I change the variable example1 by calling pop, which removes one of the last element on it, it actually changes the value of test1 and test2 when I call it, as you can see here. So how do we fix this? Well, there are a number of ways. There's a really convoluted way, and I'd really like to do the convoluted way because that's how we get most of our practice in. So, well, I'll start by showing you how to do a shallow copy. The shallow copy using a spread operator is the easiest way, and that will work only for, oh, I should console log it too, I guess. Yeah. So, line 103 is this console log here. this shallow copy will only work as long as there are not arrays inside of the array, such as this y that we have here. Notice how y equals an array of arrays, and you can see all the you can see the nested structure of it, and it's just like having spaghetti list, baking list, and cleaning supplies list. And in your cleaning supplies, you might have bathroom cleaning supplies, and bedroom cleaning supplies, and garage cleaning supplies, whatever. The point is you have lists inside of lists, and a shallow copy will only copy using the spread operator, this 3 dots. It will make a shallow copy of just these 3 arrays, but it will not go any deeper than that one, than the first level. So in other words, this whole array can be copied using this syntax here. But if I change any one of these inside, and these are referenced, like we referenced test1 to example 1, we'll have that same problem of values changing that we don't expect them to change if we apply something like sort, because sort changes the original array. So since we love recursion, and since we've been doing all these, we've been having so much fun with recursive functions, I'm going to make a really convoluted and obtuse, basically. But I'm going to use an example, a solution I should say, convoluted solution. But I'm going to use an example I pre-prepared because I tried writing it a few times and it just no fast way of doing all this. So all I've done here is created some arrays, some names, and then after this comma here, an array. Let's change our indenting a bit just so that it makes sense. Where are we at? Okay, so the last element of this main array, as you can see, my text editor is telling me where it ends. So I'm actually 1 in too deep. There we go. There we go. So this is another multi-dimensional array. I've got these values inside of my square brackets, which might be a little bit confusing and hard to see here, but you'll notice that this array is just an array of, or a list of names, text, and then the last element is another array, and this array is a text string, then comma, and then all these numbers. I just put them on one line because, you know, it's easier to read, but if you want to keep a consistent format, you can break them into sections like this if you want. But then the last element of this inside array, so there's a main array, the last element of the main array is another array with text and numbers, and the last element of that array is an object. And then inside my object, remember, it's just key value pairs, so you can name these whatever you want. I just decided to name it another key, ABC, and then some values attached to them. So that's my names object, and what I want to do is copy all of this without the references ever getting changed down the road by accidentally applying a sort or something like that to a reference or a pointed another pointed list. So in this case, I'm going to show you, well, I'll show you all of them, I guess. So there's the simple copy method, which is just assigning it as names. This is that reference pointer or whatever. That's just going to call this, but if we change this at all, our simple copy is going to change with it, and it's not going to keep those values. So let's say I wanted to use this somewhere else, like I wanted to use one to check to print out a sorted list and another one to print out a reverse sorted list. Applying that method to the same function would permanently change it to either sorted or reverse sorted. You couldn't have one instance of both because every time you apply the method it would change the other one, right? That's an example of why this wouldn't work. So like a shallow copy using that spread operator, is our spread, the ellipsis I think is the other way of saying it. This will copy everything and make its own instance of it. So if I then sort names by alphabetical order, it won't change the shallow names variable. They'll stay out of order. But the issue with it is these inner, the reason why it's shallow is these inner lists will still contain references. And if changed, they will accidentally update unbeknownst to us to our shallow names. And again, just applying the sort, for example. If I sorted these numbers in ascending order as opposed to descending, which they're almost descending, but not quite because the 2 should be over there, so it's actually a good example. But if we tried sorting these, it would change itself inside of shallow names because the names reference only goes one layer deep. It only copies these values and this one array. But everything inside of this array as a reference from names is going to be subject to change, and we don't want that. So I'm going to call, well, let's just set an example first so you can see where we're at so far, make sure we don't have any errors. It's always a good place to start. And just so that we can print out what do I want to do? I want to print out a console log for all of the names individually so that when it does change we can see the difference. Otherwise we'd just keep seeing the changed list as opposed to the original and the changed list. It would just show us twice if we didn't if I didn't make a function that just goes through and console logs each one individually. Because console logging I'll make it more clear. Console logging just names and just shallow names as these change, they're gonna get updated and changed in here too, so we won't have anything to compare it to. But if I console log each of the individual items from the list before I change it, then it'll be in the console log before it's changed, and we'll have something to reference for the updates. Hopefully that makes sense. So the idea is we want to get a deep copy of names, and to do that we're going to make well, there is a much simpler way, but I'm going to do it the recursive programming practice way because that's it's more fun. So I'm going to make a function which we haven't made yet, so I'll call this custom array copy. I'll just say item for now because I'm not sure what I want to call it. So essentially, I want to make a function that copies, not just references, another array and all of its sub-elements. This is the point to this function. Because when I do this assignment, we have a problem. Even shallowly, we have a problem because everything is just a reference to names, and any changes to names then changes simple copy. If I use this syntax, where I create an array using the brackets again and using the assignment, but I'm creating an array out of the spread syntax, and spread what? It says spread name, and that's where it gets its array values from. No problem, one level deep. This is 99% of the time you can do this and you'll never have an issue, and this is why it never came up for me for the longest time, because I constantly use the spread operator and I'm constantly assigning new variables to every list I get, because for me it helps me just sort through the code logically. Now, when I want to make a deep names copy though, this is going to have to take in an object. Yeah, so this is going to take in an object, and then I want it to call itself recursively as long as there are arrays inside of that object, to keep checking inside of the object for more arrays, and then apply the same function to all of my arrays one at a time if they're not just individual values. So how I'm going to go about doing that is I'll start with a condition here. If the type of the input, that's what I'll call it. This will be easier to think about if I call it something that makes sense. It's always good to have good variable names. So if my input does not equal a type of object, then there's nothing to do with it, right? So let's just return the function then. no, not the function. We want to return the input because we don't want to lose values as we copy and sort them, right? We want to add them to we're going to build a result, and then once we've gone through everything, we're just going to output the result. And then we can say deep names equals the result of our function called on an object, which has many layers deep and multidimensional, but we don't know how many dimensions or how deep it goes yet. We just know that it goes deep. Now, we need, we're going to need that output object. So let's just create that now. Output object equals, so I'm going to use another method here called isArray, and isArray is built onto, remember, capital A for array objects. It's a built-in for all arrays, but I want to apply this, and it's just a true-false check of anything that you put in for its parameters. So I'm going to say that this output object, just for now, is going to be true or false based on if it's an array. That way I can reuse the same variable instead of having a whole bunch of different variable names. And I'm going to call my results, and I'm going to accumulate up in a result so that I can spit that out. That's sort of the plan. So at the end I'm going to spit out my answer, and I'm going to accumulate that answer in this TMP result thing. Yeah, just for now we'll leave it like that. So if output object is true, so I could say equals true. That's a built-in too. You can't. It's a keyword. You can use true, but you can't use it as a variable. But just to show you some different ways of looking at code and stuff. Anything that you wrap in parentheses is called an expression, and an expression evaluates to true or false. Or if you put like 2 + 2, it'll evaluate to 4. But just putting in an object, if it exists, it'll be true. If it doesn't exist, or if its value is literally false, then it will return false. So that's just another way of writing an if statement. Yeah, so if it's true, I want my TMP result is going to equal an array. Because what I'm asking is, if this is an array, then obviously the output that I get is also going to be an array. That makes sense to me. We could put the curly braces around here too. Again, it's not necessary, only because it's inline. So if there's only one line to your if statement, that's kind of recursive in itself. If there's only one statement in your if statement, then you don't need them. So if it's not an array, and what we said is an object, so if it's either an object, with the key value pairs, or it's an array, which is an indexed list. Like these are indexed lists. So it's either, because the function exits if it's not either an array or an object. And then the next check I'm going to do is this is going to evaluate to true if it's an array, false if it's not an array. And since we only have 2 possible outcomes, this is good enough for our messy code. Result, we don't know what it's going to be yet. And then if output object is true, that means it's an array, so your result becomes an array. Else TMP result is an object. So I'll make an empty object just with the curly braces there. That makes sense to me. Let's just check to see if we have any errors yet. It shouldn't spit anything out, but if there are errors, it would spit out an error, but we're good. So now I need to, I guess I'll show you another way, like a cleaner way of doing this. And again, this is like refactoring. So after you write out your thing logically, then you can go back and write it so it looks cleaner or makes more sense. But another way of doing an inline if statement and assigning something based on a true or false comparison, you could just use the question mark. So again, you use the parentheses, and whatever evaluates to true and false in the parentheses, you can say the result equals an empty array if this is true, and then separated by a colon. Result equals an empty object if output object is false. And the reason why we're checking if this is true or false is because we're checking the array the array, what do you call that? Like the programming language is primitive object, but built-in. Array is a built-in data type. And it's got a built-in method called isArray that will return whatever we give it. So remember we said custom array copy names, and names is this big data chunk here. So it's going to go through that and check if what we're looking at is an array or an object, because the output thing that we want is a copy. So a copy is going to have the exact same data type. Probably not even useful as I finish writing this, because it might just automatically it might just automatically assign itself, because JavaScript is flexible like that. But writing it out explicitly is always easier to reason through when you're stepping through your code. So moving forward, I need a current value so I can store something that I'm working on temporarily as I loop through my object. And we're going to loop through our object using for_in. So another way of using a for method is with the in keyword, and that's the way to iterate through objects. We haven't done that yet today, but that's sort of this is what we've been building up to, this whole dynamic recursive function and getting a deep copy of our data. So for_in is looping through an object that has keys instead of indexes, whereas if I did for let I equals blah blah blah, like I did for that loop, where was it? Up here, where I explicitly defined a variable as 0, and then I told it what our condition is. This is that true false statement, and then what to do with each iteration so that it doesn't loop infinitely. Objects can be just done with a for_in statement, and this is a variable, anything you want. Var key, don't use var because variable key in input, and input is the thing that we drop into our function. It's the argument that we gave it. So when we check if it's an object, it's just going to spit it back. If it's just a value, we don't need to do anything more, just give it back the value. And the reason is because we're going to call this recursively for every element in our array, and we're going to do that in our for statement. So let's just keep this simple though. So for every key that's in an input object, because we're assuming it's not, not assuming, we actually know that it's not any other data type other than an array or an object. Now I'm going to set that current value to what's the input key. So as I iterate through, this is a loop, I'm going to check this input that we got, which is this array, or whatever array that we give it, but just right now for our purposes we're giving it this array, and the current key, which is going to give me the current value of that of the array that we're iterating through, which is what we want. So that's a good start. And this is where we're going to call our code recursively, because we're going to perform that same check. Yeah, so our result here is either an array or an object, which is good. We're going to give it our key. So what we're saying is whatever this key is, we're going to make another one in our result variable. And then after we're all done, we're going to spit the result back out. But for now, we're just going to say for every key in input, the current value equals this input key, and then we're going to say result key equals custom array copy current value. Now, this is the recursive part, and that's why I've been stumbling here, just to make sure I got my logic right. So for every key in input, we're going to set a current value to whatever the input is at the key. And then we want result key here, which is, we could have just reused output object, I guess, but we'll keep it as is for now, just to see if this works logically, and then you can fiddle with the code and clean it up afterwards. But just getting it running first and having the code and everything on there is what's most important. And especially when you're working with recursion, because it gets complicated, and that's why I take a hell of a long time to go through these. So basically what it's doing is it's checking to see if the current is this an array? No. Then it just returns the current element. Is this an array? No. Then it just returns the current element. And it builds up this result. And result is going to be the same object as our original, but it's going to be copied in depth without any references, so that when we apply a sort or something like that, it's not going to change the other or any other instances of that reference. So in other words, when it finally gets through all of these names and it keeps spitting out just input, 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 it's going to come to this spot here, and this element, all of this is one element in the array, and all of this would be pointed as a reference if you simply said simple copy equals names, or if you do shallow copy names, it'll work for the first bit. All of this, it'll make its own instance. So if I sorted names, this would be fine. Shallow names would still be the original, the unsorted version. But if I sorted something inside of it, like these numbers here, because they're embedded as elements inside of another array, these ones would be subject to change if there was a sort. And that's the complicated part about working with the sort method, but I'm trying to fix that by creating a function here that does a deep copy. And by deep copy, I mean no matter how many instances depth you have, this recursive function call is just going to keep, it spits out the result, spits out, and then it's like, oh, it's an array. So if it's an array or an object, you just go through this for loop. And inside that for loop, it says, hey, the current value is whatever the value is of what I'm iterating through right now. And then the result key is going to call this same function. So it's going to go through every one of these and say, is this an array? No. Output that value. Is this an array? No. Output that value. And it's basically just one at a time stepping through the entire data structure of the object, and it's building a new one. And then at the very end, after it's done all this, we can just return result, because we're going to use whatever this function spits out. Like you give it an input, spits out, oops, what did I just do? Hide defunct? There you go. Where was it? Oh yeah, so whatever you put in, it's going to spit something out, and when I'm calling it, I'm calling this function and giving it something to copy, and it's basically just building a copy of that object by stepping through every key in it, if there's a key, and if there's no key, it's just returning whatever the current value is, because the current value is either just a string or it's just a number. And the recursive part comes in when it steps through depth. So when you have an array inside of the array, then it says, okay, let's start this process all over again. Is this an array? No. 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 Is this an array? No, but it's an object. And that's where we got our object call here. So if it's an object, if it's not an object, just return the value. But if it is an object, then do all of this. And all of this includes calling itself again to fix our copy problem. So hopefully, if I've managed to do everything, let's just see. Okay, no errors. That's a good start. Now, to test if this works, I'm going to have to do a sort of some sort. But to test the deep, yeah, I'm going to have to... Which element is this? So, index number 10, I'm going to apply a sort on this one here. See these numbers here? And the shallow copy is going to be making reference to the original names. And it's going to be changed too. And that's going to be the unexpected behavior, because we're assuming that we've copied names into a new variable here using our spread operator to get a full copy, not just a reference. And that's going to fail, I think. Let's see. Let's see. We'll operate on simple copy names because we made it, and that's sort of the point. 10 is the index. And we're going to apply sort. Now, deep copy name should be above it though. And remember, because of hoisting, this function doesn't matter that it's below its call, other than like variables need to be called after they're declared, but functions are hoisted to the top of the, what do they call it, the render chain, I guess. Not sure exactly, don't quote me on that, but I bet you my face is probably covering some of this. Okay. So yeah, I'm gonna apply my sort, and then I need to console log it afterwards. I guess I can do it up here. Console log deep names. And when we check it here, what we're looking for is shallow names is going to be changed. So line 131 is this one here. So you can see these numbers have now been sorted in order, but I never once called sort on shallow names. I called sort on simple copy names, index number 10. But we'll notice, if we got this all right, in console log deep names, where we used our function to do our deep copy, that's line 137. You notice these are still out of order as we expected them to be, or wanted them to be. So this, again, is the terrible practice. Don't do it this way. There's a much simpler way. And actually, before we close out, I'm definitely going to show you the simple way. The simple way, or the best method, is to use a built-in called JSON. And JSON has a method called parse. And inside of your parse, you're just going to use another JSON method. So this built-in JSON method turns our array into a string and then parses that string into JSON, and JSON is literally just JavaScript object notation. It's a way of storing data that's really easy to access from either web browsers or apps or C applications or Visual Basic or anything basically can read JSON data. And JSON data is just the object notation with the key value pairs separated by a colon and inserting the value afterwards. And you can nest your JSON objects like that too if you want. Do anything. They're really, really handy and useful. But the JSON, I guess it's a library, but it's like a built-in library that's been adopted by the JavaScript standard now, so you can just use it without any imports or complicated statements or anything like that. So this may look a little bit convoluted, but when you understand what a method is, because you understand what a function is, you can understand then that a built-in object called JSON that has a parser, and a parser means that it splits something up into its corresponding values. So if you make a string out of your object and then make a JSON object out of it again, you're making a direct deep copy of the entire object in one line without any of this complicated nonsense. But the complicated nonsense is mostly the fun. So that's pretty much all I wanted to get into, I think. I'm going to do a lot of playing around. But just keep in mind things like the array index, using these square brackets right directly after the array is how you call the value straight from the index. A string will convert itself into a number without producing any errors. But if you start trying to do math on that number, it's going to add them together like strings and give you the wrong index, just as an example. You can do math in here. Inside the square brackets, you can do it inside of function calls, and sort even takes another function I guess we could get into. You can create sort always needs two arguments, because what it's doing is comparing two values in the array, and then if one turns out to be negative, then it swaps them. I can't remember which side is which, but if you do a minus b, and if the value turns out negative, it says, okay, you're in the other order. For ascending order, for descending, it would just be the opposite. B minus a, not plus, but, and yeah, I can't remember which is which, but there you go. So if I do b minus a, it's descending, so what it's it's taking the next element in the array and comparing it to the first one. So let's say you had 6 and then 5. So if 5 turned out, if 5 was B and 6 was A, it would basically be saying 5 minus 6 equals minus 1. And anything that this returns as a negative, it says, okay, you're bigger than the other one, you swap it. And then it just steps through the entire array that way. That's unnecessary if you're doing an ascending order, because that's the default, is the ascending. But what's really, really crucial to remember, and I can't stress enough, is that some methods change the original array. And if you have references to the original array, even if you think that you're assigning them values, if you make reference to them, use this notation all the time. And if you have a deep object like this, or you plan on having a deep object down the road, just start yourself off with one of these when you want to make a copy and play around with the copy without affecting the original. You'll see if I do, let's apply a sort to this. But we'll do sort in reverse like we just did before, because now I remember that we can do that. So B minus A. So what we're doing is we're telling this to just sort in descending order, just like I showed you above here. But you'll notice that it does not affect the original, and that is what is most important here. Save. So simple sort, console log is 160. We're looking for line 160, that's this one here. Oh, I guess, yeah, that'll only work for numbers. You can't really do that with letters. How do you return? I wonder now. Ah, that's right. I'll just use, if I can't remember, I'll just use another method I know. So reverse just does the opposite of whatever order it's currently in, it does the opposite. So hopefully that'll work. 159. Where is it? 160. Is that right? We got Chris, Adam, Cindy, Alana. Chris, Adam, Cindy, Alana. Yeah, I didn't do anything. Let's try that. Meh, this is a long video. I think my brain's just too tired to be working with this, but reverse is another method. Let's just look that one up because I already started it. JavaScript reverse method. How do we use the reverse method properly? Oh yeah. So I had it right. There's just some little quirks with it. What is it? Strings come before numbers. Capital letters are different from regular letters, and mixing them obviously doesn't work when you have mixed values like I tried to do with mine. But yeah, just look at the documentation, play around with it. Maybe I forgot to console log it. Could be why. Simple way dot reverse. Save. Line 159. Oh, there we go. Yeah, I just didn't console log it because I was too tired. But anyway, you'll see that it has reversed these, but it's not exactly accurate. So, best to write your own function. Oh, let's try that sort again. I really want to see if this works. Line 159. There we go. So now the reverse alphabetical order. So what I did first was apply the sort method, and then after it was sorted, I applied the reverse method. But you'll notice that if I look at names, that's the original one, the one I copied from using our recursive function there. This one hasn't been changed even though I applied a sort and reverse on our copy. So best when you're using data to always work with copies and leave the original as original. That way you don't unintentionally start changing things that other things make reference to. which happens a lot, and it's really hard to catch that type of error. Other useful methods, since we're in the methods episode, let me just comment out a bunch of this stuff. Yeah, there we go. Just before we close out, we should go over some other useful methods. So we did what? Pop, push, and sort, reverse. We used log, isArray. We used array.isArray, array.from we've made an array out of another array, and we used the arguments keyword and made an array out of arguments. And let's throw some stuff on a web page, because we haven't been doing much visual stuff lately, and it's been mostly just code and console work. So let's actually get some visual representations of stuff. Let's move this back onto here. Save this. And again, this is my console. This is the web page, and yeah, this is where we are putting our code. So nothing crazy complicated. I'm just moving things around so that we can play with the browser a little bit. So let's use the map method for this one. So first I'm going to need my body of my document get elements by tag name, because I'm going to get the element from my web page, which is this thing right here. I just assign it ID just to show you around some new stuff. So body tag is what we'll call it. And instead of pulling it from tag name, I'll say just get elements by ID, because that's the standard way you'll mostly be doing it. There's no point in keep doing it the hard way. We'll let you see something a little bit different. How do I want to do that? I'll just make a regular list, I guess. Let array items equal list 1 item 2 something else in here. And again, this can be anything you want. I'm just assigning variable values to our array, because I'm going to make a list out of them. So to create HTML elements, all you need to do is use the document.create element. So I'm going to start with oh, actually, you know what? I have some. Let's just do that. I'll speed things up a little bit here. Didn't realize I already had an example of this. So I'm just, same thing as before, creating a list item, and then I'm pushing a couple things on to help practice with the push. Now I'm going to do a function a method called map, and map cycles through all the elements in the arrays, and it pushes something back out. And this is particularly useful in React frameworks, because you want to push out active elements or components that get rendered to your web page. But in our case, we're just going to do, just for an example and changing things up, I'm going to do an anonymous function call, but again, no different from the arrow function call or anything like that. And this has the same value, index, array, but you can't use the array word because array is a keyword, so I will just change these to shorthand, again, to help you get used to just seeing it, because you're going to use that a lot, these array methods, and they almost always have the value index array. And it's based on order, so whichever thing you put in first. If I call this idx and I call this val, it doesn't change. This is still going to be your value, and this is still going to be your index, and it's just going to make your code hard to understand. So it's not that you can't do it different, it's just that it's more useful to use it practically. Now, inside of that function, I'm going to maybe, you know what, I'm gonna play with this a little bit more actually. I'm gonna make a function that creates items. Why not? We've gone this far. We might as well go the whole 9, right? So let new list item equal document.create element. And this is just a built-in method to the built-in document object. The document object is everything. That's how we get our body tag from the document object. Well, we also get the getElementById method from the body object. And we're going to use this to attach things to it. So the HTML list element, what kind of element am I creating? I'm going to create an li, which is a list element, and new li dot, we'll use another method here, inner HTML. So this is actually a property, it's not a method. And the difference is this isn't acting on anything, it's a value of this list item. And a list item inside of like HTML, I don't know if you know unordered lists and ordered lists, so it's UL and OL for ordered lists, but you just create list items by going like this. Item 1, item 2 in HTML. So all I'm doing with this function here, or this property here, is I'm going to create a I'm going to create a new list element based on whatever input I get from this function. And then I'm just going to return something. What am I returning? The list. Well, I guess I have to create the OL and stuff first, don't I? Oh, I'll just use this. ID equals my list. So what I'm going to do is say, I'm going to grab this, but my code has to run after the list is made. I'll probably change this up in the when I finish off, but anyway. So what do we need? So I need a variable that grabs that new list tag I created, and the ID I gave it was my list. Oh, back and forth. My list. No space. So what I'm going to do is, the end of this function is just going to append it. No, that's not how I do it. Yes, because I'm going to append the list items inside of it. So my new li. Now, when I map through every item in my list, and that's just this one, this one, this one, and then another element I added on here, and another element I added on here, this map function is going to go through each one of them and apply this function to each one of them individually, and return an array if you need it, but I'm just going to manhandle this map and misuse it because we can, just to show you that we can misuse stuff. So map usually outputs an array, but you don't need the output. In this case, I'm going to run it the same as a for each, where it just does something for each time. But I've got a function, so I can just say HTML list item, and that function will just take in the value. So as I go through HTML list 1 becomes the value here, and then I run function, and then I run the function with this as an input, and that function is right here, and all this does is create a new element. Inside of its inner HTML, it just assigns that text that comes from my array. So for every element in my array, I'm going to run this function that creates a list item and appends it. This method here appends to any HTML tag that you've grabbed from this getElementById. So I'm gonna snag that list and then add to it another HTML element which I'm creating in here, and I'm going to do that for every single time I have for every element that I have in this array of HTML lists. So basically I'm just taking whatever text I put in and spitting it back out. And as you can see here, if I zoom in a bit, you've got item 1. Ugh, look at all this formatting. There we go. So you'll notice I only wrote 2 list items in here, item 1 and item 2 in HTML. And then list item 1, 2, and 3 come from the code down here. And then the new pushed items and again pushed items in here. And if you inspect the code using this little arrow on the top left of the console thingy, you can actually check and see exactly what it's done in rendering the web browser, the web page. So now we can start making like real life things that we can click and act on. And I guess starting in the talks moving forward, we'll get a little bit more visual, so it's not just all code and text and console logs and stuff like that. So I hope that was useful. I hope it was practical. I know it was a lot of repetition and back and forth, but for me, that's what I found was most helpful. And the videos that I found when I was learning to code in JavaScript they always got it perfect on the first try, and it made it impossible to see what it looks like to fumble through it and figure it out. A lot of people get the idea that code is just programming or code is just constantly typing and then you're done. But most of what you do is, 10% typing, and the rest of the time you're just walking yourself through it and making a tiny adjustment, save, refresh, over and over again. That tedious process of coding is usually lost when you look at a tutorial of people getting it perfect on the first try, because most programming doesn't work like that. So simple things like when you've been doing it for a long time like I have, even this type of stuff, I have to stop and think. Like I'll still trip on my words while I'm speaking to you over it, because it's not easy. It's code. It gets easier as you practice it, but anybody can make mistakes. Anybody can forget, like the sort method changes references to other keys and indexes, and again with all the methods, like nobody memorizes all these methods. We're constantly just checking, what do you call it? Table of contents. There we go. We're constantly checking the documentation, like MDN or W3 Schools or Stack Exchange, Stack Overflow, that kind of thing. You just look up, like, somebody's had your problem, whatever your problem is. Somebody's had it before and they've asked for it. So just type your question into Google and you'll find it. Oh yeah, shift is really important. Unshift is really important. It's the same as pop and push, but from the front of the array instead of the back. But as you can see, you can go through this and have a lot of fun just playing with new stuff. And every day you could learn it, because it doesn't take hardly any time to learn a new method, right? You can just look it up, type it in, and it works. And then when you're building little projects or giving yourself challenges, do like I did and think like, oh, I wonder if I can throw a function in here instead of just a name. Like for create element, I've never tried this before, but maybe create element will accept a function that just returns what I wanted it to. Let's see if that worked. No, returns an error. See, little stuff like that, you can just play around with it and see what works and what doesn't, because sometimes you can throw unexpected things inside of other things, and sometimes you just can't, which I find really fun. Because I bet get li. I bet I could write this same function and call it in here, and I bet that would work. Yeah, see, little things like this is interesting, and you can kind of get a sense for what I was trying to figure out just a few seconds ago. I couldn't take this entire function and stick it in here and get that to work. But just by giving it a variable name, or I could have just as easily said, function get li, and defined it like a regular variable, regular function. Oops. Sorry, I'll try and make it look like something familiar at least. So it's just a regular function. All it does is return the text li, and all this thing needs, the create element method, all it needs is a text representation of of an HTML key. So that could be a div tag, it could be a script tag. If you want to create a script that adds a script to another script, you can do that too. But anyway, you get the idea. Like what you can do with this though, what I know does work, is you could say new script.src, because source is an attribute from the script tag. Like if we didn't want to write all our code inside of the same script, we could just say src equals and then put in, you know, path to script.js, for example. And this is what you'd normally do when you're writing programs, is you just have a script that does one thing and that's it, and then you'd have multiple script tags so that if there's an error with one of your scripts, you know exactly where to find it, because it'll tell you which line from which file, and it doesn't disrupt the logic of all your other scripts. And I mean, it might crash the page, but yeah. So you could just do equals and then again just give it a path to another script.js or whatever, and then you can just you could create scripts within a script and yeah, that's sort of what we're getting. Recursion is awesome. Functions are useful, and if it's not clear what they were useful for, hopefully now that you have a bunch of methods that take in functions as arguments, then you have a better idea of what functions can be useful for. So with that, I will bid you adieu, and hopefully you found that helpful. Give me some feedback, likes, comments, subscribe, and all that kind of jazz. Free content's free. Have fun.